going to be looking at bases. Now, I know what you might be thinking. Baseball. No, not those bases. Not first base, second base, third base, home. No. Bases numerically, mathematically. And what does a base have to do with what do you mean? Okay. Well, I want to review a couple terms, concepts, and the main thing I want you to get is how these two are separate. They are very much related, but they are different. So I'm emphasizing the difference between them. Okay? And they are, first of all, the face value. That's the quantity that's assigned to the number. All right? The place value is the position in the numeral. So are these the same? No, not at all. The face value is the quantity assigned to it. The place value is the position in the numeral. Okay, so what do you mean? All right, 384. Now, what are our place values? Well, you know this. There's the ones, the tens, and the 100. So this is a 4 in the ones place. Okay. This is an 8 in the tens place value. This is a 3 in the hundreds place value. Okay, so the face value and the place value, now the place value is where it is, the face value is what it is. If I change the number around, we had 384. If I make 834 or 483 or whatever, the place values are still the same. There's a digit in the hundreds and the tens and the ones. The numerals are the same, okay, but the face value changes as we move it around, okay? So understand that difference. Now, we're going to, as I said, look at bases. And what is the base that we use all the time? The base system. I don't have a clue, Mr. Harmon. I've never thought about it. Okay. How many fingers normally? Okay, and you know, there are some people that have part missing digits or whatever, but generally 10. How do we count? 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then what do? We move over to a new place value, don't we? We put that 1 in the tens place, and you start over again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 1, 2, 0, 1, 2, 3, 4. So what base do we use? Yeah, base 10. Okay, so we're going to start by looking at base 10. Write 10 to the 0th power as a standard numeral. Do you remember what any base to the 0th power is? That's 1. Okay, what is 10 to the 1st as a standard numeral? It means without the exponent. 10. What's 10 squared? Right, 100. 10 times 10. All right, now be careful. You think I'm going to go 10 cubed, right? No. What is 10 to the negative 1 power? Oh, that's negative 10. You're doing opposite with addition and subtraction. Are we adding and subtracting? Multiplying and dividing. So we had 10 to the first is 10. 10 squared is 100. What's 10 to the negative first? Okay, so what's our answer? 1/10. And we're writing in a decimal form, and I could have a fraction 1/10. What is 10 to the negative second? 1/100th. Okay. So if we're looking at this number, 4,892 and 67 tenths. Okay. Now let's break that down into its place value and its face value. Okay. There are the place values, the thousands, hundreds, tens, ones, tenths, and hundreds. Now, let me mention this. This is kind of like, you remember earlier on we were looking at number line, and I did that 1, 2, 3, 4, and then -4, -3, -2, -1, and you might have gone. But I said, I've seen that. Okay, in place value, what do? You follow a pattern, and you just follow the pattern. Don't even think. We have 100,000, 10,000, thousands. Then hundreds, tenths, ones. So what comes next? You've been going 100, 10, 1, 100, especially if you start out in the trillions. 100, tens, 1, 100, tens, 1. Once, tenths, hundreds. There ain't no once. Okay, so understand that's missing. The pattern breaks right there. Okay, it's kind of like when you count the centuries. You go back to BC, AD, and there's a difference there. You know, because we're switching from one to the other. Well, we're switching from the positive exponents to negative exponents. There is no once place. It starts with tenths. I know you probably knew that, but it's easy to lose that in generating a pattern. Okay, so there's our place value. What's the face value for our 4,892 and 67 hundredths? Okay, there's a 4 in the thousands. There's an 8 in the hundreds. There's a 9 in the tens, a 2 in the ones, a 6 goes in the tenths, and a 7 goes into hundredths. So you see there's the place value and the face value. The face value, that is a 4, 8, 9, 2, 6, 7. But then it's worth 4,000 because it is 4 in the thousands. All right, so let's stretch that out and explain the meaning. You have 4,000 plus 800 plus 90 plus 2 plus 6 tenths plus 7 hundredths. Now let's take that and rewrite that in terms of place value. 4 times 1,000 and 8 times so forth. Now let's go ahead and instead of all the zeros, let's use exponents. 4, 10 cubed, 8, 10 squared, 9, 10 to the first, 2 ones, and remember ones are 10 to the 0th power. 6, 10 to the negative first, 7, 10 negative second. Now, if one of these numbers would have been a 0, technically, can you leave, like if this was 4,890, could I leave that 0 out of there? No, it would move things around. So we would have to have 0 times 10 to whatever exponent. So my point is this. Whatever your highest exponent is and your lowest exponent, you need to have every exponent in between. Now we're going to be doing that same. You say, I know this. What are you doing? It's so silly. I know all this. I learned it, back in elementary school. Right, with base 10, you're familiar with it. But everything I just did, when we switch to base 5 or 4 or 2 or 16, you've got to be able to get the concept. So when we start going over those other bases, if you then go back and watch what I just did that you might have, glazed over. All right, so let's talk about comparing decimals, and I mentioned base 5. Okay, if I start out here with 10 to the 0, that's our ones column. Well, in base 5, it's 5 to the 0. And then we have 10 to the first, 5 to the first. So you have your 10s, well, we have our 5s. So this is our 1s and then our 5s. Next you have hundreds. Well, I have my, that's 10 squared. I have my 5 squareds, my 25s. And then is going to be my 125s. Then my 625s. And I don't know it after that, whatever 5 to the 5th power and 5 to the 6th power is. Here it's really easy, 1, 10, 100,000, 10,000, 100,000, millions. 1, 5, 25, 125, 625, whatever it is, and whatever it is again. Okay? So it's the same pattern, but we're multiplying by 5 instead of by 10. Okay, let's talk about the place value. Okay, if I have a 1 in base 5, we write that with a sub 5. Now I'm just going to say 1 base 5 rather than 1 sub 5. I'll try to say it that way, and then we call it 1. So you don't write a 10 here. It is understood to be in base 10 if there is no base noted as a subscript. Okay, the next number in base 5 is, of course, 2 base 5, which is a 2 in base 10. Then a 3 base 5 and 3, 4 base 5 and 4. Now, this is the problem that students can make a mistake with. Don't do this. You think base 5 goes up to 5. Does base 10 go up to 10? No. Base 10. What are the 10 digits? 0 to 9. When you get to 10, you've moved over to another column. Remember in your arithmetic in elementary school how you would take a 1 from a 10s column and rename it as 10? That's 2 digits. We can't write 10 in base 10 with 1 digit. So we stop base 10 at 9, and then we move to the next one. We move over 1 column, right, in place value. Same thing is true with all other bases. Whatever base you're in, the highest number is always 1 less. Always, 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 always. All right? So what's going to come next? We can't go above 4. So we have to shift over to the next one. It's going to be 1, 0, base 5. That means 1, 5, and no 1s. And 1, 5, and no 1s is 5. 6 is 1, 5, and 1, 1. That's 6. 1, 5, and 2 1s. 1, 5, and 3 1s. 1, 5, I'm saying 1 in base 5, and 4 1s. That's 9. Now I've gone up to 4, so I have to move 1 more on this column, so that's going to be 2, 0, not 20, 2, 0, base 5 is 10. So that's how you deal with the bases. We're going to do some more. Write 1, 3, 4, base 5, write it in base 10. Well, there's a 1 in 5 squared. There's a 3 in 5 to the first. There's a 4 in 5 to 0. It would be like in base 10, it'd be the hundreds, the 10s, and the 1s. So what does that mean? Okay, that means there's 1 5 squareds. What's that? 25. So this is 25. There's 3 5s. That's 15. There are 4, remember this is 1s, 4 1s. So we have 25 and 15 is 40 and 4. So 1, 3, 4 base 5 is 44 in base 10. I think I got it. Okay, let's do some more. 101 base 2. Now, base 2 is 1s, 2s, 4s, 8s, and so on. So I have 1, what's 2 squared? 4. That's a 4. I have no, to the first, 2's, and 1, 1. Okay, so this is a 4 plus 0 plus 1. That's 5 in base 10. 2 squared, one of those, no 2 to the first, and one of the 2 zeros, 2 to the 0th power. 4 plus 1 equals 5. Another base is base 16. Ooh, you know what we do with that? Well, how many numbers do we have in base 10? 10. What are they? 0 to 9, right? So we need a digit to handle the concept of 10. I want to do that in one digit. I can't use numerals. They're already used all over the place. I don't have any more numerals. Okay? So I could make up some fancy squiggles or use something that you already know. If you don't use numerals, what else do you know that we could use? Yeah, letters. So 10 becomes A, 11, B, 12, C, 13, D, 14, E, and 15, which is our highest in base 16, is going to be F. Here's the chart on that. The digit in base 16, A means 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Okay, when there's the base is smaller than 10, we use fewer letters. If the base is bigger than 10, fewer numbers, I'm sorry. If the base is bigger than 10, we use letters to cover it. Now, if I was working with base 12, then it would stop right here. There'd just be, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A and B. That would be the 11 numbers. So I can have any base, of course, beyond 16, which you won't see, but if it was base 23, we just keep going after F and use the letters as they continue on. Let's work with a base 12 number. A5, 3 in base 12. That's a 3, well, let's look at it in order. In the first place value, I have an A, and that's the 12 squared. So it's an A face value in 12 squared. It's a 5 face value in 12 to the 1. It's a 3 in 12 to the 0. Well, remember, anything to the 0th power is 1, so this is just plus 3. This is 12s. So I have 5 times 12. That's 60. This is 12 squared. That's 144. Verify it if you need to. Now, what is A? A means 10. So I have 10 12 squareds, 10 144s. So this is 1440 in base 10. This is 60. This is 3. That's 1503 in base 10. I think you need to practice this a little bit. So go ahead and work on your skill check. Now, all we have to do is go backwards. If you're given a base 10, go back to base 2 or 5 or whatever it is. You've learned most of the concept. We're just going to tweak it a little bit in the chart table. So let's look at some examples. Write 28 in base 2. Remember, 2 to 0 is 1. These are the 2s, the 4s, the 8s, the 16s, and the 32s. I don't have face value there. I have the base value. I'm specifically talking about what is its base 10 value. Okay, and I just told you 2 to the 5th is 32. 2 to the 4th is 16, 8, 4, 2, and 1. So what I want to do is I want to take this 28 and I want to break it apart into as many of each of these as I need to. Now with base 2, remember you only have zeros or ones. All of the other bases, you have to say, well, how many of these could I? No, you only have one of them. That's it. That's binary, on or off. All right? So if I have 28 to start with, do I have any groups of 32? No, of course not. There aren't going to be any that go here. Are there any 16s? Sure. There's going to be one of those. When I subtract 16, what do I get? I have 12 left over. So is there room enough for an 8? Sure. There's one 8. Minus 8, what do I have? 4. So there's 1 4. When I subtract the 4, what's left? 0. Now, can I skip these? No, no, no. Remember, what do you do if there aren't any 2s? What do you do if there aren't any 1s? Now, I don't need this leading 0. So my answer is 1 1 1 0 0 base 2. There's 1 16, 1 8, and 1 4, and you add them up and you get 28. A 16, an 8, and a 4. 43 in base 5. Well, 5 cubed, that's 125. 5 squareds are 25s. 5s and always 1s. I don't have to worry about this. It's not big enough. Okay? How many 25s are there in 43? There's just one of them. So when I subtract 25 from this, what do I get? 18. How many 5s are there in 18? 3. That's 15. When I subtract the 15, I have 3 left over, and that means I'm going to have 3 1s. Not 133, 133 base 5 is the same as 43 in our normal base 10. 133. 125, 3 5s, and 3 1s. 2,564 in base 16. Okay, so this 16 to 0, 1, 16, 16 times 16, 16 times 16 times 16. That's 4,096, 256, 16, and of course always, have you seen the pattern, 1s there. Do I have enough? No, I don't have enough for this one. How many 256s are there in 2,564? Well, you know that. That's times 10, right? That would be 2,560. And that's going to leave us just 4 left over. So how do I write 10? I can't use a digit for that. I only go to 9. What's the code letter for 10? A. So there's only a 4 left over. Are there any 16s? No. And how many 1s do I have? 4. A04 base 16. By the way, the bigger the bases, the fewer number of digits. Bases smaller than base 10 will have sometimes more digits. Bases they're picky. I mean, you must do everything exactly in the right place. Notice how the table, we used that same concept both times, but when you are given a base number, like the number in base 5, Then you had the place value and the face value, and you just wrote it down. So if I had, 3, 2, 4, base 5, I would put the 4 and 5 to the 0, the 2 and the 3 under, and I just have to figure it out. It's a little bit trickier what we just did going backwards, because you have to figure out in that base what is the 0th power, the first, the second, the third. And then you have to take the base 10 number and see how many of those there is and use up all of the value of your base 10 number in those chunks, those increments. And they depend on which base it is. Every base has different, except for the ones. Then you have 5s and 25s, or 6 and 36s. So there's no exactness to it. There's just the pattern that we've been looking at. Okay, watch this as you need to. Go back and review it. You might need to do that. This is a little bit of an involved section, so work carefully. Make sure you get all the trickiness, and you'll do fine.
Hello, Colt Connors. I hear that you're taking on that mildly maniacal mathematician M cubed. I plan to help you along the way. I have my own reasons for wanting to see M cubed put in his place. Whenever I have information as to M cube's activities, I'll send you one of these messages. Watch it, and then destroy it. Now to business. A few days ago, I was able to dress up like the singing burrito delivery girl and slip an infinitesimal camera into M cube's takeout dinner box. Now I have the prototype of his latest gadget. It's some sort of manual sorting machine. After taking a good look at it, you won't think M cube's trickery is so tricky after all. The cards are numbered in a binary system. With some practice, you can figure out the system before he starts throwing numbers at you like whipped cream pies. Now here's how to make your own sorting system. You'll need 15 note cards. Number them 1 through 15 on the bottom. Then number the top of the cards using the corresponding base 2 numbering system beginning with 0001 to 1111. Now punch a hole above each of the binary numbers 4 digits. Make sure all of the holes on all of the cards line up. Above each one in the number, cut an opening all the way to the top of the card. By using a thin object, like a straightened paperclip, you can sort the cards by inserting the straightened paperclip into the ones place will result in all the even numbers remaining and all the odd falling away. Now with only 4 sorts, you can find any of the 15 cards. Try it a few times to find different numbers. I'm not sure what M cubed plans to use his sorting machine for, but it might have something to do with computers. The binary system is the basis for some types of computer programming. Whatever his plan, hopefully this information will help you take him by surprise. All right, Colt, I've done what I could. The rest is up to you. I'll keep you updated on M cube's activities. Until next time.